Okay, welcome to this video here for Material Science 410, where we discuss some additional details on the preparation of a technical memo. And really we'll start by thinking about general expectations for executing lab work. And so the success of a technical memo ultimately depends on how successful our lab procedure has been. So it starts with the idea of being very prepared to execute the lab procedures and characterization. So, in general, if when we're visiting a wet lab or a device or characterization lab, one has to be very prepared for the work. So this involves reading the procedure very carefully and the lab manual thoroughly, and we expect the same of students in Material Science 410. Typically, students who sort of understand and write down their own purpose, hypothesis, and a general plan for the procedure end up with appropriate notes in their lab notebook, and this better prepares them to prepare and report in the form of a technical memo on their successful experiment. Okay, so we want to be, by being prepared, we're going to be much more efficient in lab, and we're going to be able to take more, take advantage of that efficiency and be more organized in note-taking during the lab and have more success in our reports. So with that in mind, what we do not want to do is simply photocopy or hand copy the lab manual. This is not a way to prepare oneself for the lab work. By simply interpreting such information, the lab manual, interpreting that for yourself, putting that into your own writing and your own formatted notes to prepare yourself for lab work, you will end up kind of with greater understanding in the nuances and details of the experiment and characterization methods, and be ready to kind of interpret data correctly and understand themes and fundamentals of the science in question or the engineering kind of topic at hand. Okay, so in that regard, this is an opportunity for you to note any questions or concerns that you may have in executing the actual experimental methods, and bring those to your supervisor or your instructor as you kind of ready yourself for the lab work. During lab, what we want to do is record descriptive and thorough observations. Okay, so this means kind of readying our lab notebook for this sort of area of the experiment. And so we're going to have a section devoted to, where we would write down results, observations, and this would help us get a high quality report at the end. We're also going to write down materials and equipment used, so this might be instrument manufacturer, model numbers, any additional accessories or features that we've implemented on the characterization instruments, and of course listing what materials have been studied there, including details such as standards or benchmark materials if they're applied. So clear notes will allow us to easily review the report in the future and ultimately write that successful report in an easier way. Okay, so having actual tables ready to organize data as it's coming in is a great idea. This can again help you envision what type of data you will get ahead of time, but also kind of not miss any key data or metrics needed for this report. So organizing tables is a nice way to make sure you've included all the details or opportunities to get all the details when you execute that lab. So you can see here that a well-organized and complete lab book will actually result in success in writing the complete and accurate report. Okay, so for Material Science 410, we'll see that lab reports are going to be written individually unless otherwise instructed. We'll use the technical memo template that's available on Canvas. Brief video speaking to the sort of format there is also available on Canvas. And we want to be sure to refer to any of these documents as we prep to report for our lab. So we're going to look at, you should look at resources like the Guide to Writing Technical Memos. This is our PowerPoint slideshow. You're also going to look at some additional resources and links such as manuals and textbooks here to help you. And you always want, especially for a course, to consider if there's a grading rubric to make sure you understand what you're responsible for and the expectations of you in this report. Okay, so for Lab 1 as an example, you see sort of a report guidelines listed on Canvas here. What we expect for the specifics in your report: name, date, title, abstract, table of contents, background, project description, results, conclusions, and references in an ACS style format. More detail to the sort of memo format has been provided in another video, as mentioned. And our rubric is going to be available here. And so you see that lab evaluated at 50 points is broken down with the above sort of kind of allocation of smaller point values to each of the components in the memo. Okay. In the event that an experimental data is not speaking to the expected result, that is fine. You would not be penalized provided that lab steps were executed correctly and that you made reference to what the expectation was and hypothesized what had perhaps impacted that non-result from your actual lab work. Okay, so keep that in mind. Students often ask whether or not wrong data should be omitted or even spoken to, and we do want to include it, but we want to interpret it as well. Okay, so technical memos will be used for our reports. Information regarding lab contents and rubrics should be provided to you. And this memo is a written document typically seen from a member in an organization, written for one or more readers within that same organization. And therefore that memo format is something that we want to always apply to any experimental reports so that the readers know exactly what to expect and what sections to go to. It helps disseminate the information quickly and efficiently within the organization. The writing the writing style has the purpose of being effective and efficient for reviewing a task. Okay, so how we present this work will allow for efficiency in this regard, and will allow us to interpret sort of the ultimate lab work and speak to the goals of the study in a better way. Okay, and so we should see details on how a task was carried out, experimental methods, etc. in our report as well. So some general resources that you might turn to for technical writing are shown here. So here are some textbooks and other resources that will help you. The ACS style guide we've turned to for various things like references at the least, but it actually speaks to units, abbreviations, and other sort of formatting themes that we want to see in material science for 10 technical reports. Okay, so as we've done a quick overview before, we expect to see an abstract, body, and conclusions sort of section to our general technical reports. But as we dig deeper into the body, we'll touch on some additional kind of thoughts here for that. So we're in the body of the memo at this point. And we're going to see either as part of the abstract or as the first section of the body, a sort of table of contents, sort of bullet point outline of what the follow-up sections will be. We expect to see a bit of a background and project description. This could be in the abstract or it could be early in the body. Depends on your approach to the abstract section. But it's often important to include 1 to 2 paragraphs here, again, with a purpose sentence and some key concepts that help us understand why the experiment and characterization has been carried out. Okay, and we also want to reference literature whenever possible here to show what is known in the field and what is known from other experiments perhaps done in the organization. So include references as needed to show that we're respecting what is known. Okay, results. Again, we want to give a nice subheading within each body paragraph and section to make sure we know what is coming. So this could be a section on X-ray diffraction as an example, and then we'll speak to that overall characterization in 1 to 2 paragraphs with additional subheadings for perhaps the material studied by XRD. Okay, so we're going to see brief descriptions of how each experiment was carried out, characterization methods, and the results obtained, and any interpretation thereof would be supported by figures, plots, and tables, etc., that strategically reinforce conclusions or findings from those experiments. And again, literature reference here is going to help us show that the interpretation is anchored against something that's already known in the literature. So literature can sort of show that the author of this memo is not pulling interpretations out of nowhere, but actually basing them on knowledge in the literature. Okay, being concise is very important. So often you start by putting all thoughts down into a paragraph and then evolving that paragraph into a shorter and shorter format as you target the most concise paragraph possible without eliminating some of the kind of key takeaways or key statements that you need to make. So we want to say things with as few words as possible. Lab reports should be thorough, and we want to avoid repetition whenever possible. Of course, the conclusion section will re-emphasize the most important aspects of the study, so don't confuse that with repetition. The memo should be clear, and it should flow logically. So typically that would mean discussing characterization of materials after the discussion of how those materials have been made. There would be key statements for the purpose and goals of each study or sub-study outlined. For example, in an XRD paragraph, you might say the XRD characterization was used to investigate the crystal structure of the materials at hand, and then follow-up interpretation would be used there or included thereafter. And in these paragraphs, you want to narrow down the key concepts that will allow you to outline and support the purpose of writing the memo. This will allow readers to enjoy the reading better and receive information quickly and clearly. Okay, so again, a key purpose of the memo, which tends to be more brief and concise than other sort of lengthy academic style reports. For general writing, what we want to do is write in the third person. So we almost always avoid using words such as I or we when we refer to the experimental procedure. So instead of saying I boiled 50 milliliters of water for 10 minutes, we instead say in the third person that 50 milliliters of water was boiled for 10 minutes. Here you can see that the third person here is specifically the 50 milliliters of water. We want to make sure we're using the correct verb tenses in our writing. General rules for verb tenses are if the experimental procedure has already been conducted, we want to use the past tense of the verb when referring to it. The purpose of the experiment was past tense. The compound was weighed, past tense. The device was prepared, past tense. Elsewhere, we want to use the present or future tense as appropriate. So for example, energy dispersive X-ray spectroscopy, EDX, is a method for determining the elemental composition of stainless steel samples. Okay, so here you can see that we've used present tense speaking to what the EDX method is useful for. In the following example, we see the next step in the investigation will be speaking to the future. So if we're in a preparation step or something, this idea of future tense is appropriate. Okay, we always want to be thinking about explaining the results in terms of what we've listed earlier as the purpose or goals. So as one is preparing a report, if you find that you are preparing a body paragraph that is outside of the purpose or goals, maybe you need to revisit the purpose of the goals section earlier in your report to make sure that they are actually inclusive of all the ideas and studies executed. Okay. If the original purpose of the experiment was achieved, explain how the results show how this was accomplished. If it wasn't achieved, explain why not and what your hypothesis is for what went wrong or what could be improved to make it better speak to the sort of purpose of the experiment. Again, a recommendation sort of towards the end of your report. Okay, so there's an example paragraph here. I'll let you pause the video and take a moment to kind of read this and see how this would speak to the purpose and goals of the sort of preparation here for working with acetic acid in vinegar for this specific kind of example. Okay, next sort of thought here is to relate the results to those of other similar experiments. So again, respecting what's known in the field. So depending on the nature of the experiment and the instructor's preference, you may need to compare your results to those of the rest of the class or compare to literature or other knowledge that you cite. Okay, so this might be a moment where you need to interact with your instructor or your supervisor in a future environment. Now for the conclusion section, what we expect there is to include summary statements and findings and make recommendations. So in an earlier video, we highlighted some examples of some technical reports, and we saw a nice recommendation listed in our first example there, and we're going to expect that of you in your 410 reports. So here, comparison of expected results with your actual results, and some key takeaways would be expected. If the experiment did not turn out exactly as expected, comment on why the results have been different and try to explain why you got the results you did and how to improve the experiment in the future. Okay, so once you've decided what might have caused an error, explain the error and how it could be avoided. This is useful for the next employee or next colleague of yours to try to improve this further, or perhaps even yourself as you repeat the experiment with more additional information based on your initial experiment. So touching on ideas like how could the setup be made more effective, or what different methods or conditions to prepare the material could have been used, what additional characterization methods would have touched on the features that are expected of the new material or device. Things like that should be touched on at this point in your conclusion paragraph. How could contamination be avoided? What more precise equipment could be used? Ideas like that are appropriate in the conclusion section here. Okay, and we mentioned the ACS style guide for references. So kind of accessing the link like you have here to help us understand the format expected for the ACS style guide is a good resource for you. Please do that. As a general sort of theme to what we see in the ACS style format for references, we see the last name listed first, the initial of the first name, the initial of the middle name as listed on the publication. So you don't want to be listing middle names if they're not provided on the publication. A semicolon to separate that first author from any follow-up authors. The next author has their last name listed first. Again, first initial of the first name and initial of the middle name as listed on the publication, and etc. Okay, so again, a semicolon to separate that second author from the third author. We're going to see that repeated. Okay, once that last author is listed, you'll see that we break away to the publication venue. So here the Journal of American Chemical Society has been abbreviated per an abbreviation that's listed in the ACS style guide. You do not want to make up your own abbreviations here. They are compiled for you in resources. Notice that this abbreviation is also in italics as the first kind of part of the publication venue and its additional numerical details for the publication. We then see the year listed after. There is no kind of punctuation to separate the abbreviation. So we don't see a semicolon or any other kind of break. The period that's included there is part of the abbreviation of society for the end of the journal name. The year here is bold. So this is a bolded font here. We see a comma to separate the bolded year from the next information where we have the volume of the journal listed next. And again, a comma separates that. Issue numbers are not included in the ACS style format. And then we finally see page range. Okay. And finalizing of the reference with a period. So notice again the volume here is in italics. And the page range is in non-italics or sort of normal type font presentation. Okay, so generally having remembered the author approach with last name, comma, initial, semicolon, repeat, you can eventually then transition into the publication journal information and the specifics of what volume, what page range list this publication. And so I tend to sort of remember that the journal name is always in italics, and then to remember the following end of the format, I remember bold, italics, normal, bin for the end. So you can come up with your own kind of reminder there for the end, but italics on the journal name and then bold, italics, normal on the remaining information. Year is bolded, volume is italics, and the page range is in normal format again. Okay. Very good. So we'll stop this video here and we'll continue in a follow-up video discussing figures and plots.